we're now working on table 2 on page 14, so make sure you're about to work on the correct table. We're using prims from AP. So using prims, so prims is a little similar to the nearest neighbour, apart from you can go from any vertex you've already been to. So it makes a minimum spanning tree. You don't have to go from the previous vertex, you can go from any you've been to. So we're going to look down here, find the shortest, so the shortest is MC, which is 7. So we're going to do AP to MC, which is 7. So we're not going to write a tour this way, we're not going to write the vertices added, we're just going to write a list of the edges in the order that they're added on. So we're not going back to AP, we're not going back to MC. MC was the second one that we added on. So now, rather than just looking down the second one, we're looking down both of these. So both of the ones we've already added on, we're going to pick the shortest from there. So we've got a choice of these numbers here, and the shortest is 6.5. So we'll write down what our shortest was. It was MC to SH, and that took us 6.5. So that means that SH was our third one added, and we don't need to add it anymore, so we can cross it out. We're now looking down all 3 columns. Your shortest is here, so it was SH to KK, and that took us 6. So we're not going back to KK, we went to it 4th. So the only place we've got to go to is to PH, and we've got a choice. We could either do it, we could either go from KK to PH, or we could go to MC to PH, and it doesn't matter at all which one you pick. So pick either one you like. I'm going to pick the KK to PH, but you could equally have picked the MC to PH, and you'd have got the same answer. And this gives us our minimum spanning tree. It doesn't actually say that you have to find the length of it, but let's find the length of it anyway. So it comes to 28. So just make sure we finished off this. So we went to PH 5th and we didn't go back to it. So the important thing is here in terms of your working, because it says working on table 2, you must do some working on table 2. So your method mark comes from having some circles and some crossings out on this table. Without those circles and crossings out, you can't get the marks. Even if this list is perfect, you can't get the marks without doing some work on the table. So you've got your method mark for doing some circles, some crossings out. You've got an independent mark for having 4 boxes on the table, or failing that 4 numbers listed here. You've got an accuracy mark for having a 3 above the SH, or having the SH appearing on the second edge here. And you've got your final accuracy mark for everything all right, so for having 1, 3, 2, 5, 4. But without anything marks on the table, you can't get any of the method or accuracy. The most you could get is 1 mark for having the boxes here. So you must do work on the table if the examiner asks you to. Hence find a lower bound. So prims on these ones here comes to 28. So lower bound, so he's deleted one of them off our table. So let's just look back at the tables that we use for table 1, and one of these has been deleted. So I think it's SB has been deleted. So we need to find the 2 shortest edges from SB. Again, this is very important. You can't just write down the numbers, you must write down the edges. So if we look back at our tables to SB, so the shortest ones, you've got SB to MC, which is 1, and you've got SB to SH, which is 5.5. So you've got to MC, which is 1, and you've got to SH, which is 5.5. Now, if you just write down the numbers, you're not going to get the marks. You have to write down the edges, so the examiner must see these edges here. And so the lower bound for the length is these 2 that we're going to add on, plus the 28 that we got plus prims. So we're going to do our 6.5 plus 28, and so that comes to 34.5 for our lower bound. Finally, given that the length of a minimum tour is t minutes, we're going to use our answers to A and B to write down the smallest interval. So we know our lower bound is 34.5, so there is no way our tour can be below 34.5. So it must be above 34.5. And then we look at our upper bounds. So we could do a tour that took us 52.5, or we could do one that took us 43.5. So if we've got a choice, we're going to pick the smallest tour. We want to do it in the least time, so we're going to pick the 43.5. So our interval is going to look like this. Now you must write it as an equation to get the marks. As you mustn't write it in words, you must write it like this to get the marks. It doesn't matter if you've got an equal sign here as well. He'll let you have that, although it's better to have it with a strict inequality here and the equal sign here.